Not long after I graduated from Barton College in Wilson, I accepted a temporary position to work in one of our highway divisions. I was a traffic technician in charge of doing field studies to determine traffic volumes, speed, and other factors that influence traffic conditions. Before I started, thinking back to what I thought about transportation, I really thought it was just roads. You would think of DOT, you would think of the yellow trucks and the roads. So then as I become an employee, and the more I work with the agency, I noticed that we have so many different disciplines and so many different units that work together to support each other. We are one of the largest state agencies in North Carolina. We have over 9,000 people in a variety of careers, including engineers, plant management experts, archaeologists, environmental specialists, and planners. We oversee more than 13,000 bridges and 81,000 miles of roadway, making us the second largest highway system in the nation. Our program also covers aviation, freight and passenger rail, bike and pedestrian greenways, the Global Trans Park in Kinston, and public transportation. But while we're always working for today, we're also planning for tomorrow. That's why we employ researchers who are working to make transportation better in the future. We have staff who are learning new and innovative ways to use cutting-edge technology like autonomous vehicles and drones. One reason I love NCDOT is we're committed to helping others. The values I've learned when I started my career here are what drives us today.
So I always like to start out when I tell people just like the fundamental definition of what photogrammetry is. And so photogrammetry is the art, science, and technology of deriving 3D information from 2D overlapping imagery. Here at NCDOT, we use aerial photography from either crewed or uncrewed vehicles. Of course, our crewed vehicles is an aircraft with a camera mounted on the belly. This camera is a large format metric camera. It was designed specifically to take measurements, and it's been geometrically corrected to reduce distortion. It was not designed to take pretty photographs. So our end product is typically geospatial data. This can range from anywhere from planimetric maps, space maps, digital terrain models, earthwork quantification, and all these products really can be used from all the way from inception of a project and through the construction phase. And that also includes planning and design. I still remember when I joined DOT on the Transportation Engineering Associate Program. This was a program designed, for fresh graduates of engineering and similar curriculums. And essentially we get a new job every 3 months, and we get to kind of go visit different units and different departments here at NCDOT and kind of essentially try to find our little niche. So when I saw the word photogrammetry, I had no idea what it was. I just saw the word photo in it, and it kind of, perked up my interest a little bit. So I went and visited them on the program and ended up falling in love with what they do. So that's how I kind of ended up here.
I found surveying kind of late in life. My son was 10 years old, and it actually started with GPS. I was super interested in GPS, so I took a certificate program at my local community college, and it was GIS GPS. So started with that, and I got a job with a local surveyor. So I found surveying, and I loved it. Continued, went to a 2-year degree, surveying technology. Done that, worked in boundary surveying. As soon as I finished it, there's one 4-year geomatics degree in the state in North Carolina, A&T, so I applied. I went the first year, is online, so part-time, and NCDOT had a summer internship program, and I applied. They hired me, and I worked that summer, and they kept me. And transportation and geomatics, it was officially my thing. Loved it, don't want to do anything else.
It was about loving the structures. It's like I love to have some design, have something to think about. Okay, I had a problem, I need to fix that. Okay, this cannot be done like this way. I need to solve it another way. There's a lot of different branches in engineering, but I feel the structure or the civil engineering is the best thing for me. I'm originally from Egypt. I took my bachelor's degree in civil engineering in Egypt. When I moved to the US, I was like, okay, my big concern is how will I find a new job here? But 80% of the people around me was working with the state. So I was like, okay, let's try to apply on this field. And then I was like, okay, there's something called photogrammetry in it. It's like, we don't have that branch in engineering in Egypt. It's like, I did some research about it. It's like, okay, how it works. And then got like very interested about how it works, how weird the glass is, how we can see 3D, how we can put pictures together and get some information about any project from just having some pictures. So like I fall in love with it. I was like, yeah, I want to be here.
Of course, there's a lot of planning involved with capturing the imagery. Once we get a project and we get a boundary and we figure out what product we need, we then start planning our mission. We want to plan where each photograph needs to be taken in space, as well as our ground control panels that we use to tie that imagery to the ground and extract that 3D information accurately to give to our customers. Typically, we use the crewed aircraft for the larger projects and projects that we need to, extract planimetric features from. So we use UAS vehicles, which stands for either uncrewed aircraft system or otherwise known as unmanned aircraft system. This is another term that's commonly used as drone that you'll hear. Photogrammetry, we're taking overlapping photographs of a project. So our missions are flown in a straight line, and these photographs are taken at a set interval, right? So maybe every 2 seconds, 2.5 seconds, and they're overlapping roughly 60%, of image 1, you can see, 60% of the same ground coverage on image 2, right? And so the apparent shift, so that the observer is the camera, right? And it's changing locations, but the feature, the transportation road that we're mapping, of course, is staying still. Parallax is the apparent shift in an object when the observer changes positions. We can then calculate parallax via the parallax equation and use that along with a lot of other variables that we know, like focal length, your ground height, your distance between those two consecutive photographs that you're using to take the measurement from. And you can extract 3D information like height of an object as well as your X and Y coordinates. We talk about image space, we think of the coordinate system in each photograph. Each individual photograph has its own coordinate system, and it's just a 2D Cartesian coordinate system that's set up. When we talk about object space, this is the space that we are in, sitting in right now, that you are, and you're on the surface of the Earth. Those are the coordinates that we are seeking, is those real-world 3D object space coordinates. So NCDOT is looking to upgrade an existing road to improve transportation efficiency. And this is a 2-lane road. We've already flown the project and acquired the imagery and taken 2D measurements on those images. So we need you to calculate the 3D coordinates and create a model to give to our design engineers and aid in the planning and design of a new feature. All right, just a quick tip: when you're doing your calculations for your model, make sure to keep an eye on your measurement units. We look forward to getting your 3D model. Thank you for being a part of the photogrammetry unit here at North Carolina Department of Transportation.